there. So once again, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@yvcc.edu and I will respond as soon as I can. Okay, good morning and welcome to Math 93. All righty. So the first thing I want to do this morning is to review the idea of inequalities and how you would go about solving an inequality and what rules pertain to inequalities. So solving an inequality is very much like solving an equation. That is to say, if we have decimals, we can multiply both sides of the inequality by 10 or 100 or 1,000, depending on how far we need to move the decimal point to get rid of it. We can multiply both sides by the least common denominator to clear the fractions. We can add the same quantity to both sides. We can subtract the same quantity from both sides. We can multiply or divide both sides of the equation by the same non-zero number. So all of those things are the same for solving an inequality versus solving an equation. The one difference is if we Maria, can you turn off your mic unless you need to speak, because we're hearing noise.
I'm sorry, I'm walking out of the classroom.
That's okay, you're fine. Anyway, we can multiply or divide both sides of an inequality by a negative number. We change the direction of the inequality. So let's say I had negative 2x is less than 10. So to solve this inequality, I would divide both sides by negative 2. Because I divided both sides by a negative number, I would change the direction of the inequality sign. Okay, or let's say I had, let's see, negative 1/2 x greater than or equal to 7. In this case, I would multiply both sides by negative 2, which would give me x and negative 14. And again, I would change the direction of the inequality sign since I multiplied by a negative number. So again, multiplying or dividing by a negative number, both sides, you change the direction of the inequality symbol. Otherwise, it's just like solving equations. Any questions about that before we go on? If you want to look at more information pertaining to inequalities, section 2.7 of the textbook covers that topic. Okay, all right, now what we're going to be doing today is we're going to be graphing inequalities, linear inequalities. Graphing linear inequalities is similar but not exactly like graphing equations. So for instance, let's say we have, let me get a problem here. We have x plus y is less than 2, okay? And we want to solve this inequality. So we would, or we want to solve, let me rephrase that. We want to, it's Monday, I'm still waking up. We want to graph this thing, all right? There are a couple of ways we can do it. One of them is to take the inequality and write it, solving it for y. That is, put it in somewhat of a slope-intercept form. Okay? Now, if I looked at the related equation, I'd have y equals negative x plus 2. And this would have a slope of negative 1 and a y-intercept of 2. So what I could do to graph that thing, let's see here, using this information, a slope of negative 1 and a y-intercept of 2, I could say, well, the y-intercept is 2, and the slope was negative 1, so it's going to go down 1 and over 1, okay? And then I could go back and draw a line through those points. Now, if we look at the actual inequality, it said y is less than negative x plus 2. And I just graphed y is equal to. So we need to go back here to this graph, and we need to fix it somewhat. We're not going to include that solid line because that's the equal to part. So instead, I'm going to come back and turn it into a dotted line. What that does, it doesn't include the line, but it establishes a boundary. Okay, now I'm going to go back here to this. It says y is less than that. Okay, so looking at our graph, where would less than the line be? It would be below it. So our solution is what's called a half plane. Think of this whole thing extending on in all directions. You've got this plane, and we're cutting it in half with that dotted line. And the solution is everything below that dotted line. Okay, think of it this way. Think of it as this is your property, and over here, this is your neighbor's property. This is why I'm not an art teacher. Okay, so you own all of this property, and this dotted line is the fence separating the properties. It establishes the boundaries, but the fence belongs to the neighbor. So even though the fence establishes the boundary, it's not your fence. So your property is everything up to, but not including the fence. Does that make sense? Any questions there? All right, we're going to go back to the same situation here. Let me find it. Okay, and let's make a slight change in the problem. Let's say that it's this originally, which means it would now be that. So x plus y less than or equal to 2, x less than or equal to negative x plus 2. We would still have the same line establishing the boundary, only now y is less than or equal to. So how does that affect our answer? Well, now the fence is ours. The property boundary is established by the fence, but our property is everything including the fence. So if the inequality includes as part of it an equal sign, the line is solid, not dotted. If it doesn't include it, it's dotted. Okay, and I also want to point out this is a line. It's not a line segment. It's not a ray. It's a line. And what do I mean by all of that? Well, a line has arrows at both ends and continues in both directions. A ray has a point and then an arrow going one direction. A line segment has points at both ends. So we're using a line to establish the boundary. That's going to be real important again when we get to doing this on WebAssign, which I'm going to show you in a little bit. Okay, any questions so far? All right, I'm going to switch screens, and let's see here. We're going to get rid of that, and we're going to open up this screen, and we're going to look at this. Okay, and let me make sure. So can everybody see the graphing screen that's got an X and Y coordinate plane graphed? Have I clicked on the right buttons?
Yeah.
Okay, great. Thank you. Thank you. All right. Let's take a look at another problem. Oh boy, are we having problems? Here we go. That's 5x plus 4y greater than or equal to 20. Okay, now I'm going to use the same technique I used a bit ago, and that is I'm going to put this in slope-intercept form. And then I'm going to go back and look at a different way of doing it for those of you that are more comfortable just plotting points. this says 5x plus 4y is greater than or equal to 20. So the first thing I'm going to do is solve it for y. So I'll subtract 5x from both sides, giving me 4y greater than or equal to negative 5x plus 20. Go ahead and erase this little extra stuff here just because it's bothering me. All right. Then I'm going to divide each term by 4 on both sides of the inequality. So I get y greater than or equal to negative 5/4 x plus 5. This is now in slope-intercept form. Y equals mx plus b, where m is the slope. So in this case, the slope is 5/4 and b is the y-intercept. So b is 5. Okay. Now, I'm going to plot the y-intercept. And then using the slope, going from left to right, I'm going to go down 5 and over 4. Down 5 and over 4. Down 5 and over 4. And I just need to plot a few points to get the line. 2 of them's enough, but the more points you plot, the easier it is to line things up. So now my question is, I'm gonna draw a line through those dots. Is it going to be a solid line or is it going to be a dotted line?
It looks like it will be a solid line.
It would be a solid line. That is correct, because it includes the equal sign. So I'm going to go back over here and draw a solid line. Oops. Well, I tried. Let's see what's going on here. There we go. Didn't have my stylus quite. Looks like I missed the line here. Let's try one more time there. See if I can do a better job. You know what? I can do this using this program right here. So there we go. Aha. Okay. So here is solid line. Okay. Now, are we going to shade the area that is below or above? Well, it says y is greater than or equal to, so we're going to shade the area that is above the line. Okay with that? So the solution would be everything above and including the solid line. All right, now I want to go back and I want to do this problem again. Let's see here. We have 5x plus 4y is greater than or equal to 20. This time, instead of putting the inequality in slope-intercept form and using the slope and the y-intercept to get the graph, we're going to just plot some points. In fact, let's find the X and Y intercepts. We don't have to find those specific points, but I'm going to do that. So to find the x-intercept, we'll set y equal to 0. To find the y-intercept, we'll set x equal to 0. Okay, so we're going to complete those two ordered pairs. If y is 0, we get 5x plus 4 times 0 greater than or equal to 20. 5x is greater than or equal to 20. Divide by 5, x is greater than or equal to 4. But in fact, we want to just solve it in terms of an equation. So let's do this. Let's just make this an equation. So let's go back and do this. Okay, let's just look at it. 5x plus 4y equals 20. So now we get 5x plus 4 times 0 equals 20. 5x equals 20. Why am I just looking at the equation instead of the inequality? Because I want to establish just where that straight line is. Okay, dividing by 5, x is 4. So we have an x-intercept at 4, 0. Okay, now let's find the y-intercept. The y-intercept x is 0. So we have 5 times 0 plus 4y equals 20. 4y equals 20. Y equals 5. So 0, 5 is our y-intercept. So now we've got 2 points established. Okay, now let's go back to our original. It's greater than or equal to. So because it includes the equal to, that means that it includes the line. So it's going to be a solid line. Let's see here if I can get this to line up correctly. Okay. So here's that and here's that. Now, we need to establish which side of the line we're on. Is it above or below? So what we're going to do is we're going to pick a test point. The test point can be any point on the graph that's not on the line. A nice one to pick, if it's available, would be the origin, 0, 0. So what I'm going to do is I'm going to see, does that point make this statement true? If it does, then we're going to shade on the side of the line where the 0, 0 is. If it makes it false, we know it's on the other side. Okay, let's 0, 0. If x is 0 and y is 0, what do we get? We get 0 greater than or equal to 20. Is that true? No. So this point is not on the line, therefore it's on the other side of the line. Excuse me, this point is not in the solution. Of course, it's not on the line, but it's not in the solution. So our graph will be everything above and including the line. Let's go back and look at the previous page. Can you see that? Okay, now I plotted different points, but it's still the same solution. Okay, so you can use slope-intercept form to establish the y-intercept and the slope and get a second point that way, or you can find two-ordered pairs to do that. Okay, let's see here. I want to look at a few more of these, and then I want to go and look at WebAssign to make sure you understand how to do things on WebAssign. Okay, let's take a look at this one. 3x minus 2y greater than 6. I'm going to use slope-intercept form on this problem. So to solve it for y, I would, let's see here, I would subtract 3x. So I get negative 2y greater than negative 3x plus 6. Now I deliberately picked this problem because the next step is going to be to divide each piece by negative 2. So on the left I get y. Negative 3x over negative 2 becomes positive 3/2 x. And a positive 6 divided by a negative 2 becomes a negative or a minus 3. But because I divided both sides of the inequality by a negative number, we're going to change the direction of the inequality sign. Okay? Now, the equation related to that would be y equals 3/2 x minus 3. So the slope would be 3/2, and the y-intercept would be negative 3. So I'm going to plot negative 3, and then using the slope, I'm going to go up 3 and over 2. Okay. Now, when I go to actually graph that line through those points, notice it does not include the equal. So that means that my line is going to be dotted or dashed, if you want to say that. Okay, so there's my boundary. It says y is less than, so that would be below the dotted line. So the solution is everything below, but not including the dotted line. Any questions on that? All right. We're going to do this same problem again. 3x minus 2y is greater than 6. And I'm going to use the 2-point method. And I know I'm going back and forth, because I want to make sure you can use either one of these methods. The slope-intercept form is quicker to do, but not everyone likes to do it that way. So I want to make sure you have a good foundation of doing it either way. Okay, so now I'm going to look at 3x minus 2y equals 6. Okay, and I'm going to make a table. And again, I'm going to use X and Y intercepts. I don't have to, but I'm just doing that for now. If y is 0, we get 3x minus 2 times 0 equals 6. 3x equals 6, x equals 2. If x is 0, we get 3 times 0 minus 2y equals 6. Negative 2y equals 6. Y equals negative 3. So x is 2, y is 0 is there. X is 0, y is negative 3 is there. It's a dotted line because it doesn't include equals. Let's see here. Okay. Once again, I need to pick a test point. Again, the origin works, so I use that. Is that true? Is 0 greater than 6? No, it's not. So that's not the correct side. So the graph is on that side. So the solution is everything below, but not including the dotted line. And let's look at the previous thing. See, again, it's the same graph. I just went about it a different way. Okay, so there's two different methods of solving the inequality. There's the linear inequality. There's putting it in slope-intercept form and looking at the equation, plotting the y-intercept and the slope to establish where the line is. There's just finding two ordered pairs and doing it that way. If it includes equals, it's a solid line. If it doesn't include it, it's a dotted line. Okay, I want to look at a few more inequalities just to kind of remind you of some things, and then we'll take a look at using WebAssign. All right, let's say we have this, y greater than negative 3. Well, the equation related to that would be y equals negative 3. An equation that's in the form of just y, no x involved, y equals a constant, is a horizontal line. So that would be a line, a horizontal line going through negative 3. But because it doesn't include the equals, it wouldn't be a solid line. It would be a dotted line. So it's going to look like that. Now, it says y is greater than negative 3. So where would greater than negative 3 be? It would be above. So the solution here is everything above, but not including that dotted line. Any questions on that one? Okay, let's take a look at another one. And this says x is greater than or equal to negative 4. The related equation to this would be x equals negative 4. Well, whereas y equals a constant is a horizontal line, x equals a constant is a vertical line. And if we look at our inequality, it includes the equal sign. So I'm going to draw a solid line through x equals negative 4. But it says x is greater than or equal to. Well, now all of a sudden we don't have above and below because it's a vertical line. But where is x greater than negative 4? Over on the right side of the graph, of the line. So the solution here is the solid line going through x equals negative 4 and everything to the right of it. Any questions about that? All right. So now, let's see here. I'm going to close that up. and open up that. And let's make sure that you can see it. So can everybody see it says graph the inequality x plus y less than 2?
Yeah.
Yes.
Okay, great. So what I want to do is I want to show you how you go about using WebAssign. And this is very important because it's not real intuitive. So there's going to be lots of people that aren't going to look at this video. They're going to email me and say, I can't get it to work. And I'll probably say, go look at the video. Okay, anyway. So let me do something here. Let's see. Let's open this so I have a place to write. And go down here. Okay. It says x plus y is less than 2. All right. So what I'm going to do now, I've got x plus y is less than 2. Can you see where I'm writing there on the screen?
Yes.
Yes.
Okay, super. Sometimes I don't push the right button, so that's why I always want to make sure. Okay, let's do this using the point method. Okay, so x plus y equals 2. If I found the x and y intercepts, let's see, if y is 2, excuse me, if y is 0, x is 2. And then if x is 0, y is 2. So we need to plot the 2 points, 2, 0, and 0, 2. Okay. It is a dotted line. Okay. So a dashed line. And let's see here. Now, what I'm going to do, I'm going to go back and share the WebAssign screen. All right. Now, this is important. So first thing, I need to draw a straight line that is dotted, okay? Not a ray, not a line segment, but a line. If we look at the options over here on the left, the second one down, if I click on it once, there's a line, there's a ray, and there's a line segment. I don't want to choose that, and I don't want to choose that. I want to choose the solid line, and I need to click on it. In fact, let me go back here. You click on it twice. When it turns blue, it's ready to go. Okay. Now, I had the point 2, 0 and 0, 2. 2, 0 is here. 0, 2 is there. Okay. That establishes where the line is. But recall, it was x, in fact, you can see it right up here, x plus y less than 2. So it's not a solid line. How do I make it a dotted line? Well, I go over here to where it says line 1. In fact, they keep using dash and I use dot, same thing. And I'm going to click on that, which makes it a dashed line. Okay, that's the way you do that. So I've got to make sure that I've got this blue. I use that, not down here. Don't use that. Use the line, plot 2 points, come over here and change it to be a dashed line if that's what you need. Oops, I just put a point there that I shouldn't have. So now I'm in trouble. We'll come back here and we'll start over. And we have that, and that, and that, and that, and that. Okay? Now, I need to establish, is it above or below that line? So let's go back to this screen. And we need to pick a point that's not on the line. I should have done that back in the previous screen, but the origin is not on the point. If I put the origin in there, I get 0 less than 2. Is that true? Yes, it is. So that means that I'm going to pick down here below. So I'm going to click on fill and then click that. Oops. Okay. So there is the solution. Let's see if it's right. and it checks it, so it says it is. All right. So what I want to do, I'm going to clear this whole thing out and I'm going to go over it again just to make sure you understand. So I plotted a couple of points. So clicked here, 2, 0, 0, 2, and then that, and made it dashed. Oh, you know what? Oh, that second point, I didn't get it quite where I wanted it. How can I fix that? Well, if I go here and I click on this, notice right here, those are the two sets of coordinates for the points. Well, I wanted 0, 2, and I wanted 2, 0, and 0, 2. So I can go in here and I can change that to the correct point rather than starting over. Now, what I just did is going to be important because sometimes the points that you get, the coordinates aren't nice numbers. They might be fractions like 2/17 or something. And there's hardly a way you're going to accurately graph 2/17. But this allows you to go over and put in any value that you want to make it easier to graph. Okay? Any questions about that? Let's take a look. I'll tell you what, let's do this one right here. Okay? 7x minus 5y is greater than 15. 7x minus 5y is greater than 15. And okay, I'm going to stop sharing that and go back here. And let's see, shall we use slope-intercept form or the two-point method? Somebody tell me. No one wants to speak?
Slope.
Slope-intercept form? Okay, so I'm going to solve this for y. Subtract 7x, negative 5y greater than negative 7x plus 15. Divide by negative 5y, 7/5 x, negative 3. Oh, and I'm going to change the direction of the inequality because I divided both sides by a negative number. So looking at the equivalent equation, I have a slope of 7/5 and a y-intercept of negative 3. Okay. Note also that it does not include equal, so it's going to be a dashed line. So I'm going to plot the y-intercept and then use the slope of 7/5, excuse me, to get the line. Okay, so I'm going to go back here, share this screen. So I want a solid line. So I've clicked on that. I want the y-intercept of negative 3. Then I'm going to go up 7, 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4, 5. Okay. I want to make that line dashed because it doesn't include the equals. Okay. Now, hopefully I won't make you dizzy going back and forth between these screens. When I solved it, put it in slope-intercept form, it said y is less than. So that means I want to graph below the dotted line. So I'm going to click fill. This thing comes up. I have to click OK. And I'm going to click below the line. And let's see if that's correct. And it is. All right. Any questions about that? So again, where people get messed up is they use this instead of this, and then all kinds of fun things happen and things don't work and you plot a whole bunch of points and can't understand why. So you really need to do it the way that I'm showing you here to be successful in WebAssign. Okay, so just a reminder, later today, I will post this video on my YouTube channel, Math with Mayo. I will be creating a new playlist there that will say Math 93 Winter 2021 or 2021. Okay, and it'll be there for you to look at if you want to go back and check it out. I will be back again at 1:15 with an office hour, which will have a different Zoom number than this one. Any questions before we quit this session? All right, well, I'm going to stop the recording.